Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so this video is to study about the determinant of matrices. Okay, so the learning outcome, students should be able to find the minor and cofactor of a square matrix. Okay, then find the determinant of a 3 by 3 matrix using cofactors. Okay, so there are two types, two methods to determine the determinant of a matrix. First, by using the cofactor method. Okay, then another one is called as the diagonal expansion formula. Okay, so but first we look at how to determine the determinant of matrices by using the cofactor method. Okay, in order to use cofactor method, we need to know what is minor for a 3 by 3 matrix, and then from minor we can determine the cofactor. And after we know the cofactor, we can determine the determinant. Okay, so I will show you one by one. First, I will go through about minor, then we will go through about cofactor, and then lastly, I will show you how to determine the determinant. Okay, the first method is about the minor. Okay, so let's look at an example. Let's say if we have a matrix A, okay, if we have a matrix A that is equal to A11, A12, A13, A21, A22, A23, A31, A32, and A33. Okay. So, let's say if I want to find the minor of M11. From the matrix of A. Okay, so in order to find that, I will looking at the element of A11. Okay, the element of A11. So then, from the element of A11, then I will delete the row of the element, and I will delete the column of the element. So what is left with me is the A22, A23, A32, and A33. Okay, so from here we have A22, A23, A32, and A33. So from this one we multiply A22 with A33, so then I will have A22 and A33. Then I will minus with A23 and A32. Okay, so this will be my minor for M11. Okay, let me show you another example, also from the same matrix. Okay, matrix A. Now I want to find minor of, should not be off right here. Find minor M22. Okay, so in order to find the minor M22, so I should be looking at element of 22, which is the A22. So I delete the row and I delete the column of the element. So what is left with me is the A11, A13, A31, and A33. Okay, so I do the multiplication. A11 multiply with A33 minus with A13 multiply with A31. So that is the minor for M22. Okay, here is another example of matrix B. Okay, now I have a real number as the elements in the matrix. Okay, so now I want to find a minor of M11. Okay, then M12, then I want to find M13. Okay, so the M11 means I delete the first row, then I delete the first column. So what is left with me is negative 6, 3, 2, and negative 3. Okay, so we have a multiplication of negative 6 with negative 3 minus 3 multiplied with 2. Okay, so from that one we have here is 18 minus 6, so that will be equal to 12. Okay, so this is the answer for M11, for minor 11. Okay, then for M12, okay, I delete the first row, then I delete the second column. So what left is 5, 3, 4, and negative 3. Okay, then I do the multiplication. So I should have 5, negative 3, minus 3, and 4. So here will be negative 15 minus 12. So the answer for minor 1, 2 is negative 27. Alright. Okay, then for minor 1, 3. Okay, minor 1, 3, I delete the first row and I delete the third column. So I will be left with 5, negative 6, 4, and 2. Okay, so I will do the multiplication. I have here is 5, 2, minus negative 6, and 4. So equal to 10 minus negative 24. So I will have here is 34. So this 34 is the answer for minor M13. Okay, so I hope that you are now understand about the method to find the minor from a 3 by 3 matrices. Okay, so now since we already know how to find the minor, so now let's move on to the second step to determine the cofactor. Okay, from the formula you can see in this box, the cofactor, the formula is that cofactor ij is equal to negative 1 I plus j mij. Okay, the mij at the back is actually the minor. So we use the same method from the minor process and we put it into the formula of cofactor to find the cofactor. Okay, what cofactor actually did is the determination of negative symbols in front of the minor. Okay, the negative 1 to the power of I plus j. Okay, let me show you an example. Okay, from the matrix of A, let's say we have matrix A that is equal to A11, A12, A13, A21, A22, A23, and A31, A32, and A33. Okay. Okay, so now let's say I want to find the minor, the cofactor for A11, A12, A13. Okay, which means I will write it down as C11, C12, and C13, the cofactor for the position of first row and the first column. Okay, so in order to find that, we look at the formula of cofactor, which is the Cij equal to negative 1 I plus j, the Mij. So for the C11, so C11 equal to negative 1. So since the I is 1 and the J is also 1, so it will be negative 1 will be to the power of 1 plus 1 M11. Okay, so it will be negative 1 to the power of 2 multiply with M11. So what is the M11 that we already did? Sorry, I cannot find it from here. So A11, so sorry, minus M11 is actually A22, A33 minus A23 and A32. Okay. So negative 1 to the power of 2 will be a positive 1. So then the C11 will just be A22, A33 minus A23 and A32. Okay. Alright, next. Let's do for cofactor 1, 2. Okay, cofactor 1, 2 will be equal to negative 1 to the power of 1 plus 2 minus 1, 2. Alright. Okay, so we will have negative 1 to the power of 3 and minus 1, 2 is A21, A33 minus A23, A31. Okay, so since we have negative 1 to the power of negative 3, so it will stay as a negative number in front of the minor. Okay, so that is for cofactor 1, 2. Okay, now let's do for cofactor 1, 3 will be equal to negative 1 to the power of 1 plus 3. So minus 1, 3. Okay, so we have negative 1 to the power of 4 and minus 1, 3 is A21, A32 minus A22, A31. Okay, so negative 1 to the power of 4 is positive 1. So we just write it down as A21, A32 minus A22, A31. Okay, so that is how you find the cofactor for C11, C12 and C13. Okay, so now for example for cofactor is to do this matrix B and find the cofactor C11, C12 and C13. Okay, so by the formula of cofactor, so C11 we should have a negative 1 of 1 plus 1 of minus 1, 1. Okay, so this matrix B is the same matrix as we do example for minor just now. So we already have the value for minus 1, 1. Okay, so negative 1 to the power of 2 and minus M11 is equal to 12. Okay, so negative 1 to the power of 2 is 1. So the cofactor 1, 1 is equal to 12. Okay, so then next is cofactor 1, 2. The cofactor 1, 2 is equal to negative 1 to the power of 1 plus 2 M12. Okay, so a negative 1 to the power of 3. So minus M12 is equal to negative 27. Okay, so negative 1 to the power of 3 is equal to negative 1 multiplied with negative 27 is equal to 27. Alright. Okay, then we have done for C12, then for C13 is equal to negative 1 to the power of 1 plus 3 4 minus 1, 3. So negative 1 to the power of 4 and then minus 1, 3 is equal to 34. So this one will be equal to 34. So that is the answer for cofactor C11, 12, and C13. Okay, so finally we have come to the final step, which is to determine the determinant. Okay, so given here is the formula of determinant. So if we have a matrix A, we write it down as a bracket, as for modulus, the straight bracket, to determine the determinant of matrix A, equal to summation of A, I, J, and C, I, J. Okay, for any column of J. Okay. Alright, let's say, for example, if we have a matrix B, okay, we do for matrix B as I showed you before. For example, minor and cofactor 2, 5, 4, 3, negative 6, and 2, negative 4, 3, and negative 3. Okay, so back to the formula for determinant, we can see right here we have a cofactor. This is the cofactor. So inside a cofactor, formula for cofactor, we have a formula for a minor. So that's why we need to know the minor first, then we know about cofactor. Only by then we can solve to find the determinant. Okay, what does determinant add? Determinant add the value of element A, I, J that will later be multiplied with the cofactor and with the addition of summation. Okay, let me show you an example for matrix B. Okay, let's say we want to find the determinant for matrix B. Okay, so in order to find the determinant, you can choose any row or any column from the matrix. Okay, choose it to be used to find the determinant of the matrix. Okay, so for this example, I would like to choose the first row, which is the 2, 3, and negative 4. I choose it and I will use it to find the determinant of matrix B. Okay, so in order to find the determinant of matrix B, so I write it down B with a bracket like a modulus and make it equal to, okay, summation of Aij, Cij. So what is Aij? Aij is the element from the row that has been chosen. So that will be the A11, C11 plus, because of the symbol summation, A12, C12 plus A13, C13. Okay, based on the matrix of B, what is A11? Based on the matrix of B, A11 is actually 2 multiplied with C11. So what is A12? A12 is actually 3 C12. And what is A13? Is negative 4 C13. Okay, so since we have already calculated the value of C11, C12, and C13 in our previous examples, we could just key in the number into the formula. So we have already calculated the value for C11, C12, and C13 right here. So we put it into our calculation for the determinant. So that will be 2, 12 plus 3, 27 plus negative 4 multiplied with 34. So that will be 24 plus 81 minus 136, and final answer will be negative 31. Okay, so this is our answer for determinant for matrix B. Okay, now let's do another example to determine the determinant from another matrix. Okay, now we have a matrix A, a 3 by 3 matrix. Okay, we want to find the determinant for this matrix A. Okay, so as I said before, you can choose any row or any column that you want to use to calculate the determinant. Okay, so in this example, I would like to choose the second column. Okay, the second column, because this column has so many zero compared to the other rows and the other columns. So why do I want to choose this? Because the zeros will make the calculation more simple and more easier. Okay, so let me show you the example. Okay, so to find the determinant, okay, we still follow the formula from the determinant. So write it down like this to indicates the determinant. Okay, so I want to choose the second column, so then I will have A 1 2, okay, A12 C12 plus A22 C22 plus A32 C32. Alright, okay, from A12, what is A12? A12 is negative 2. Okay, then we do the formula for cofactor. The formula for cofactor will be a negative 1 to the power of 1 plus 2. Then the minor of M12. So the minor will be negative 2, negative 3, 1 and negative 4. Plus, next, which is the A22. So A22 is 0. Then we have negative 1, 2 plus 2, 3, negative 8, 1 and negative 4, plus 0, negative 1 to the power of 3 plus 2. Okay, so that one will be 3, negative 8, negative 2 and negative 3. Alright, okay, so we do the calculation here. So then we will have negative 2, so negative 1 to the power of 3. Okay, so negative 2 multiplied with negative 4 minus negative 3 multiplied with 1. Close the bracket. Okay, so for the others part at the back, which is the 0, for A22 is 0 and another one is also a 0, so it will be just be a 0 plus 0 because it multiply with a 0. So that is the reason by why I choose to select the second column as my calculation to determine the determinant, because it has 0, so it will make my calculation more easier. So I just solve for the A12. So we have negative 2 and negative 1. So this one I will have 8 plus 3. Okay, so it will be equal to 22. So this is the answer. This is the determinant for matrix A. Okay, so if you want to practice yourself, you could choose another column or another row, but make sure that you still have obtained the same answer of 22 as the determinant for this matrix. Okay, next we'll be looking at the properties of determinant 6.2.4. The first properties is multiplying a row or column by a constant. Okay, if each element of any row or column of a determinant is multiplied by a constant k, the new determinant is k times the original. Okay, which means if we have a matrix, okay, then the matrix has its own determinant. Okay, but then if the matrix is multiplied with a constant, then the determinant is also multiplied with the constant. Okay, then the second properties, row or column of 0. If every element in a row or column is 0, the value of the determinant is 0. Okay, so this is the example lah. Given that the second row in the matrix is 0, then the determinant is equal to 0. This is almost the same as the example that I have shown you before. Okay, then number 3, interchanging rows of column. Okay, if two rows or column of a determinant are interchanged, the sign of the determinant is changed. Okay, for example, look at the look at the second and the third column from this matrix and compare it to the second and the third column on the matrix on the right side. Okay, as you can see, these two columns are interchanged. So when we do the interchange, we need to add the symbol of negative for its determinant. Okay, if we change the row and column. Okay, then the number 4, identical rows or column. If two rows or column are identical, the value of determinant is equal to 0. Okay, for given example, this is a 2 by 2 matrix. The element in the first column and the second column is identical. So then the determinant will be equal to 0. Okay, then for the right example, the first and the third column are identical in terms of its element. So then if we have a determinant that is equal to 0. Okay, then the fifth properties, the determinant of matrix A and matrix transpose T are equal. Okay, if we have a transpose, for example, this is a matrix A and equal to matrix A transpose on the right side. So as long as the elements in the matrix are the same, so it will share the same number of determinant. Okay, then identity number 6. If A and B are two square matrices, so a square matrices which has the same number for column and also the same number for rows, then the determinant of AB is equal to the determinant of matrix A multiplied with the determinant of matrix B. Okay, then identity number 7. If A is a triangular matrix, then determinant of A is the product of the elements on the main diagonal. Okay, you can see that the diagonal is 4, 2, 2. Okay, since this matrix is a triangular, as you can see, the upper side of the triangular has the element, meanwhile the lower side only has 0 and 0 and 0. So to determine the determinant for this kind of matrix, you just multiply the 4, 2 and 2, which are the elements at the diagonal. Okay, then as properties number 8, if each element of any row or column of determinant A is the sum of two terms, then determinant A can be expressed as the sum of two determinant. Okay, as you can see here, this matrix has the first row has A plus alpha and B plus beta. Okay, in this situation, the determinant for this matrix will be equal to two separate matrix. Okay, will be equal to sum of two separate matrix, which is the A, B, C, D plus alpha, beta, C and D. Okay, so that is the properties for determinant. Okay, now let's discuss the second method to determine the determinant, which is by using diagonal expansion method. Okay, let's say I have matrix A that is equal to A11, A12, A13, A22, A23, A31, A32 and finally A33. Okay, so you already know how to find the determinant by using a cofactor, but now is to find the determinant by using diagonal expansion method. Okay, so the determinant of A, which could also be written as DETA, that A or this kind of A, enclosed with a modulus like bracket. Okay, then we write down the matrix. We just copy down the all of the elements in the matrix, A to 1, A to 2, okay, but we have to copy the first and the second column of the matrix and create another side on the left, on the right, A11, A12, A21, A22, A31, and A32. Okay, so this is the first step in diagonal expansion method. We take the first two columns of the matrix and create another copy on the right side of the matrix, separated by this dotted line. Okay, write it down like this. Alright. Okay, so then we do the diagonal process. We take this A11, draw an arrow like this in the direction of a diagonal. So that means we have A11 multiply A12 and A33. Sorry, not A12 but A22 and A33. Okay, that is for the first diagonal to the right side. Okay, towards to the right, plus another diagonal A12 to A23 and A31. So A12, A23 and A31. Okay, so plus another more diagonal to the right side, A13, A21 and A32. So A13, A21 and A32. Okay, so we have finished our first part of diagonal multiplication, which in the direction to the right. Okay, so next we take this whole bracket, which are the diagonal to the right side, minus with a diagonal to the left side. That is start from A12 to A21 to A33. Okay, so A12, A21, A33 plus A11, A23 to A32. A11, A23 to A32 plus another diagonal A13, A22 and A31. Okay, then we close. Okay, so now then what is left for you is to complete the multiplication and addition process for the first bracket, and then minus it with the second bracket, and then you will get your determinant. So this is the concept of using diagonal expansion method to determine the determinant. Okay, so now let's look at an example to find the determinant of this matrix B by using diagonal expansion method. Okay, so we write down the determinant of matrix B, or could also be written as like this, is equal to the matrix, okay, 5, -2, 3, 4, -3, 7. Okay, so we create another region on the right side that copy the first and second column, -2, 5, 4, -1, -2, -3. Okay, so we proceed with the diagonal multiplication. First we do the right side, -2, -2 and 7 plus -1, 3 and 4, 1, 3, and 4 plus negative 3, 5, and negative 3. Okay, so this is diagonal to the right side. Okay, minus with the diagonal to the left side. So negative 1, 5, and 7 plus negative 2, 3, and negative 3 plus negative 3, negative 2, and 4. Okay. Alright, so then we proceed with the calculation. We do all the multiplication, addition, and subtraction that involved in the calculation. So we should have 61 minus 7, okay, that is equal to 54. So 54 is the determinant for matrix B.